Alright. So for using quadratic interpolation, we need to use this formula. You still remember the linear polynomial is we just have until b1 because we just have x power of 1 linear functions. So by quadratic polynomial, we need until x power of 2. So you can see here the equations is until b2, x power of 2. Alright, so how you calculate b1 is come from the formula of slope. We see this formula before. Then for b2, the formula is also aggregating from the slope formula, which is from the first equation, the first term minus the second term divided by the size of the step. For example, here we have x0, x1, x2, so we have to minus from x2 minus x0. Okay, look at the example. Now we have the example of the question here. So we have 3 data points. x0 equal to 1, x1 equal to 4, x2 equal to 6. And then we have a corresponding fx0, fx1, fx2. So in order to find the Newton interpolations, okay, or in order to find the value of log 3 by using quadratic Newton interpolations, so we have to use formula. First of all, we have to write the formula, which is f to f equal b plus b1 x minus x plus b2 not x minus x1. Alright. So what is b naught? B naught is f x naught. So in this case, b naught is actually 0 because our fx naught is ln 1 equals 0. Next, our b1 is by using slope formula. So we have fx minus 1 minus 1. So in this case, what is the value of fx1? 1.3869 minus 0 divided by x1. So our x1 is actually equal to 4, x0 equal to 1. Okay, please give me answer. Use your own calculator and share with me the answer for B1. Right? Then next, calculate B2. B2, the formula is x2 minus by x2 minus 1, meaning that the slope for the first 2 points. And then you have minus with B1. Actually, the formula, the calculation is actually equal to B1. Okay, this is equal. Alright, so minus x2 minus x. Alright, so fx2 is 1.79 minus fx1 1.3. Okay, everything minus 1. And then x2 6 minus 1. Give me the. So now you already have your b0, b1, b2. Then you can just put into your equations f plus b1 plus x minus plus b multiplied. Then you get the x to x. Alright, so I give you at least 2 minutes to try to fill calculation for calculating this second order Newton interpolating polynomial. Right? Try to do your own calculation so you get to know how to do the calculation, get to know how to familiar with the formula. Right? So I give you 2 minutes to share with me the solutions. Remember, our question is this one. Oops. So this is our question. So please give me the value of B1, B2, and then the final one is F. Share with your friend your solution in chat box. Maybe. So we have B1. B1 is 0.4620. Okay. And then continue to calculate B2. And then finally you can calculate F. Okay, so what is B2? Please share your solution. Okay, so Hani already shared the solution. B2 is equal to the negative 0.0100678. Okay, good. And then use your B naught, B1, B2 to calculate your final functions of ln 3. So now you want to calculate when x equal to 3. So you have your B naught is 0 plus 1 is 0.6. So now 8 times x minus x naught. So your value of x is equal to 3. Your x naught is equal to 1. Okay. Then you have to add B2. So your B2 now is equal to B2 is equal to 0, negative 0, 0, 1, 0, 6, 7, 8. Okay. Maybe I put it down here. Plus negative 0.01026.8 times x 3 minus 1 3 minus 4. Okay, 3 minus 1, 3. Then finally you get your final answer. So what is F? 0.9443316. Okay, so that is your answer, 0.93394433316. Okay, so hopefully all of you get the same answer. Okay. So the final answer is equal to 0.9. Okay. Siapa boleh dapat jawapan yang lain daripada ni? So for time being, 2 of your friend get the same answer. So hopefully later when you try the same question, you also get the same answer. Okay. So if you look at the true value, okay, use your own calculator. Now use your own calculator. Give me value ln 3. What is the value for ln 3? Use your own calculator right now. Ln calculator, apa jawapan ln 3? Ani, maybe you can calculate for me. What is the answer? Okay. Okay, ln 3 is 1 equal 9,861. Okay, so this is the exact answer, exact solution. So when you use your linear polynomial or linear, okay, we call it as a linear Newton, okay, linear Newton interpolating polynomial, or we call it linear interpolation. For this, we will have the answer here too, 0.7 and 0.9. Okay, so from here we get plus plus 9, 0.9. And then when we have our quadratic, we have 0.94 something. So from this analysis, we can see that the quadratic interpolation gives a better result, meaning that it's near to the true value. Because the calculation also a bit complex compared to linear and the first two linear. So this is actually how you do your analysis of your numerical methods. You need to know which method are you going to implement, why you implement this method, and then how you can improve the method. In this case, how we can improve the method? By using small size, our interval. By using small size of our interval, we get a better result. In some cases where we use, instead of using linear interpolation, we can implement quadratic interpolations. But if you remember quadratic, the calculation is more complex. And then again, if the size of the interval is small, also you can get a better result. You can do your own analysis. For example, now you change your value of x dot 1, then x1 equal to 2, and then you have your 2.5 maybe, and then x2 equal to 3, example. So you get very close to 3. So normally the result should be better. So this is how you want to choose which method are you going to implement in your coding, because numerical method is a tool to help you to solve some mathematical problem that cannot be solved by exact solution, right? Okay, so this is how they do the calculation. Actually behind here they have out the process. So maybe I can just explain again. So first of all, calculate your B naught, meaning that you can just get the answer because B naught is equal to Fx naught is equal to 0. And then secondly, calculate your B1. Okay, I try to what we call that, try to show you the process one by one. And then next, calculate B2. So you calculate B2 if you look at the explanation just now. So we can see that the value of B2 is also the value of 1 here. Then you do your calculations. So make sure you get the same answer. And then finally, put everything in your Newton interpolating polynomial formula. Then finally, when you substitute the value of x equal to 3, then you get your answer around 0.9443316. And then this is actually what I don't know how you do your calculation just now. Some of your friends share me the answer is around 0.94336. But actually from my books, I get the answer 1.02, which is quite near with the real value. So please double check your calculations again and then make sure you do the, yeah, I think the problem is in your B not B2. Okay? Your B2 is not the same. Yes, Alia mentioned your B2 is wrong. Okay, good. So this is your B2 and then this is your B1. Okay, again, another tips for this kind of question, make sure your calculation is correct. Okay, because if you look at this, for example, if you do wrong in your B1 and then you just apply the same value in your B2, so overall the equation must be wrong. So make sure you calculate very carefully. Do it very careful. Don't do silly mistake. Don't do this mistake. Okay. All right. So now I don't want. I give you some time later to do your extra activities. Meaning that try to redo again, but right now using different set of data point. All right. Again, now we move to the third order. I don't want to explain or to show you the example for the third order. I just want to make just mention to you that the order of the polynomial can be more than 2 and infinite. For example, you want to order 10, order 20 is also okay. But you need to do it in computer. You don't need to do it in manually handwritten, right? For third order polynomial, so you can see here you have, okay, you have what here? So you have your B naught to B1, B2, and B3 because this is a third order polynomial. And then how you calculate B naught? Same like the previous example, B naught equal to Fx naught. And then how to calculate B2? Same formula for B2. It's a slope formula. And then this is the formula for B3. And then finally, you can see the formula is quite extensive for B3. Okay, but don't worry, in your exam, I will not ask you until B3. I would maybe maximum until B2. Alright, because my purpose of this actually you should do your coding part. It's not really manual calculation. The manual calculation is for you to understand the concept. But for you as a computer scientist, you need to do the coding part. How you code this? Actually, there is a repetition process. So we can just use loop and so on. Right? And then this is the example of doing third order polynomial. So you can have a look how they do the calculations. Right? Very long. So you have to calculate your B1, B2, B3 until finally you put into the equations. Then you can see, look at the answer. I just want to discuss with you about the answer. So now the answer is around 1.0751. So just now your friend shared with me the exact solutions. What is the exact solution? 1.098. So if you look at this, it's quite near with the distance between the approximate solution with the true solution is much, close compared to the previous solutions. Okay, so take note. Normally, when you do a lot of calculation, of course, you get a better result, but it's not always like that. But in some cases, yes. But you have to make sure the calculation should be very clean. There is no error in calculation because it's quite tedious. So that's why I normally, if I want to ask you until third order, I will ask you in your assignment, not in the exam. Because in your final exam, sometimes you don't have enough time to do the process. So the maximum number is until quadratic. Okay. So clear with this? Can I move to the second method? If Newton is one of the methods. Now we move to the second method that I share with you the video before about the Lagrange interpolating polynomial. Okay, this one is I for me personally I like Lagrange compared to Newton because Lagrange is more simple in terms of the formula compared to the Newton. Okay, so maybe this is the formula for Lagrange polynomials. So don't worry about the formula. Later you will see that it's not that difficult to memorize the formula. Okay, maybe I just directly look for the equation here. So you can see here we are using the same example before. Before this we used Newton method. Now we are going to use our Lagrange method. And then in this case, we have 3 data points. Okay? So if we have 3 data points, we can do second order Lagrange. In Lagrange also we have first order, second order, third order until n orders. So now we want to use second order Lagrange polynomial. Okay, for Lagrange polynomial, same like a Newton polynomial, we want to construct a function. So we have f2 because this is third point. We have 3 points, so it's a quadratic Lagrange polynomial. So f2 equals, so Lagrange we call L naught S naught. In Newton we call B naught. In Lagrange we call L naught. L represent Lagrange. L naught f x naught plus and x x. Okay. So this is for Lagrange polynomial. This is for linear. We stop until L1, but now we have to move until L2. This is the quadratic Lagrange polynomial. Okay. Or maybe I just show you linear first. Okay. Linear. So linear Lagrange polynomial. Okay. If you have any question, just let me know. Just stop me. Okay, for linear, in this case we have to find x equal to 3. Right? Remember, ln 3, x equal to 3. What the value of f3? You need to find f3. This one we are going to find using Lagrange interpolation. So now I want to use linear. I have 3 points, so I need to choose which point is suitable for me to use in order to calculate for my linear Lagrange interpolating. Okay, so I need to use x naught equal to 1, x1 equal to, I just use 2 points because it's a linear. So we know that x naught equal to 0, 1 equal to 1, Okay, in order to use Lagrange interpolating, usual you have to function, but right now function is represented by L naught X naught X1. Okay, so this is Lagrange. A bit similar with the Newton just now, but Newton they use B naught, okay, as a coefficient. So now how to calculate your Lx? Super easy. Okay, now you know that if you are replacing or you want to represent L naught. So in this case, X minus X1 divided by X minus X1. Stop. Because it's a linear. So you don't need to do like, for example, in this case, you have two items because this is quadratic. We just have 2 points, X0, X1. So we stop until here. And then replace the value. So you have here 3 minus 1. And then you have here X0 minus 1. So you have here 1 minus 4. Okay. So this is how you do the calculation for L0. And L1, you X minus X. Have here 3 minus X0 is, sorry, it's actually, so X0 equal to, then X1 equal to 4 minus. So now you have your L0 and L1, then replace the value in your, what is the value of L0? It says here negative 1 over negative 3. So you have 1 over 3 times fx0, your fx0 is equal L1. So you have 3 times fx1 is 9. So now answer is only 2 over 3 times this one. You get there. So you can see the calculation for L0 is like this. So later on when you do for your quadratic, so you have to add another terms because it's a quadratic Lagrange interpolations. So this is for linear. Okay. I move to the next. We want to see for the quadratic. Okay, I just put your linear over here, so at least you can see the continuity. Okay, now we move to the quadratic. You look at the quadratic. This is actually quadratic interpolations. So in quadratic interpolation, you need 3 points. So you have here x0, x1, x2, fx0, fx1, fx2, 3 points. So this is the formula for calculating your L0. So you know that the functions for this L0 is by f2x equal L0 x fx0 plus L1 fx1 plus L2x fx2. Because you have a 3 data point, so you need to have a 3 item in your interpolating polynomial. So now you want to calculate what is L0. Okay, so if you look at the solution here, L0 is x minus x1, x minus, because you have here x0, x1, x2. So you want to calculate for L0. So L0 will be denominator L naught, L naught. And then the rest is starting from 1, 2. Of course, you start from 0, but now you already have L naught. So you start from x naught minus x1, x dot minus x2. The numerator is based on the x value, x minus x1, x minus x2. So this value is same, should be the same. See? This is how you remember the formula. Okay, look at the second item. So now you replace. So what is x? X is equal to 3, x1, 4. x3, x2 is equal to 6. X naught 1, this one is just the same, x1, 4, x naught 1, x2, 6. So you get your Lagrange manipulator. This is actually Lagrange manipulating, we call it. Okay, next, to calculate L1. So you see here your L1, this is actually your L1. So L1, so now below here is x1, x1. See the difference. It's now x naught, now x1, x1. Okay. So we start with x1 minus x naught, and then actually we have x1 minus x1, but it becomes 0, so we exclude. That's why you have only 2 items. Okay. So we start with 0 and then 2. So put all the value, finally you get L1 equal to 1. And final one is L. So L2, you can see here we start with x2 for the denominator. So x2 minus x naught, x2 minus x1. Supposed to be you have x2 minus 2. But this one, it becomes 0, so we exclude. That's why it's not appear in the. Okay. When I put if I cannot remember the formula, I just do like this. For example, L naught is equal to x minus x1. For example, if you want to start from 0, you sometimes you forgot about the formula. So in order to calculate x, so you have x naught and x2 as your data point. So you have down here x naught minus x naught. This is actually the first item, x minus x1. This x minus x. And then this one you have x minus x. But because one where you minus it becomes 0, so you have to exclude. So that's why you just get only 2 items here. Right? Same goes to the L1. L1x will have here what is this one? X minus naught. Then you have x minus x1, x minus x1, x minus x2, x1 minus. So because statement can make come close, we cancel. So we just have two statements. So you can see it's same with this part. Okay. And the last one, this is when you cannot remember. So you can do like this. So equal to, okay, now you know that the numerator start with x2, start from 0. Then you have here x1, x2 minus, you have x minus 2 minus, cannot cancel. So that's why you have only this item, and then finally this one. That's the formula. Because actually we exclude because it's 0. Any questions so far? This is how you familiar with the, what we call that, formula, because in the exam they don't give you any formula. So, and then you don't have time to check because very limited time. You already have your experience in our midterm. So make sure you try to remember it very clearly.
Kena hafal madam formula panjang-panjang je.
Ya. Actually bila you dah buat sekali you dah boleh hafal. Macam saya cakap tadi ni kan, overall you have to know you have 3 points. Okay, you nampak X0, X1, X2. And then now you want to calculate L0. So L0, you tahu denominator dia akan start daripada X0. Dia ikut atas ni sama. Dia dua ni you can combine them. Dia ikut L0, X0. L, X1. L2, X2. The rest is based on this point. The data point. Itu yang tadi kalau you tengok saya buat L0 saya explain again. So saya punya L0, okay, my L0 is so L0x. Remember just now saya buat macam mana? So this one is X0 sebab ikut ni. L0, X0. And then we have 3 points, X1, X1. What we are doing. So we have X0, X1, X2. So we start with X0. Secondly, minus X1. Not minus X1. And then X minus L. So this is because we have 3 points, so we should have three items or 3 combination of the formula. But later on we see it will become 0. So we exclude because if this 0 is not it's math error. Kalau you tengok dalam calculator kan over 0, meaning that there is no numbers is actually over 0. So we exclude this one. This is how you familiar with the formula. Same goes to L1. So you start with X1 as a denominator, X minus X0, start from 0. Continue X1 minus X1. Okay, you see something wrong. Later you will cancel it. X minus X2. And then you have 1. So this one cancel. So if you look here, we use 1, L1, X1, X1, X1. L0, X0, X0, X0. Okay, finally L2. So it will have X0 is X2. Not continue X2 minus N1. X2 minus cancel. So that's why we have 2 terms. Then put everything in the formula. Finally, you will get all the answers here. Make sure your calculation is correct. After you get all your L0, L1, L2, put into the formula. And then finally, you will get your final answer. So this is actually the final answer for Lagrange order 2 when x equal to 3. 1.027942. So the answer is quite similar with the answer for Newton method also. But the operation is totally different. That is the beautiful of mathematics. We have different methods, but sometimes the answer is the same. Okay? Any questions so far? Ada soalan tak?
No madam, clear.
Clear But yeah, I agree with you. The calculation is quite tedious. But if you already done 1 or 2 exercise, it will be okay. But make sure you do your exercise very detailed and focused, right? Habis. Finish. Okay. So maybe we do the extra activity together. Boleh? Buat
Boleh,
sama-sama ni. Okay.
boleh.
So you try to, ni contoh atas ada. Okay, you try to give you at least 2-3 minutes, look at the questions and then try to answer the question.